So I think I have the easiest job of the morning because I get to introduce somebody who doesn't really need much of an introduction. I think I can just say Dr. Uri Treisman and sit down, perhaps. But I feel compelled to share a little bit more. As you may know, he is a professor of public affairs and mathematics at the University of Texas in Austin. And he serves on all sorts of commissions and has been named Harvard Foundation Scientist of the Year, for example. But I also know that he recently received a teaching award from his own department at the University of Texas. So he's not one of those faculty people who is just focused on research and policy issues, but is actually working closely with his students. And I know that's important to folks like yourselves who really understand the value of being in the classroom and with the teachers. In 1992, Dr. Treisman was named a MacArthur Fellow, and he's also has a BS in mathematics from the University of California at Los Angeles, and his PhD is from Berkeley, where he studied both education and math. He is really at the forefront of changing, having an impact on how we teach math and science in this country, focusing on minority achievement and the achievement gap. He works both with K-12 systems as well as at the post-secondary level. And one thing I like to say when I look at Dr. Treisman's work is that he focuses not only on how we're teaching math and what we need to do to teach math differently, but even making us think about whether we're teaching the right math. So it's really a profound conversation that he has propelled forward in this country, and we're very happy to have you here today.
There we go.
Thank you.
Thank you, Cynthia. Those are great comments. You're the great straight man for setting up this talk. Thank you, Cynthia. They always leave off my CV for some reason, where I started my education, which was Pierce Community College in the Voc Ed program with a degree in horticulture. Yes. 6 years working as a maintenance and janitorial and groundsman at Los Angeles Community College System. And just before we start talking about the possibilities and the complexities and the challenges of Dev Ed system reform, it's really useful to think about the power of individual faculty members in all of this. When I was in my 20s, never thinking that I would get a bachelor's degree or anything of that sort, just trying to figure out how to make a living, able to get some education because it was $6 a semester. If it were $100 a semester, I couldn't have done it. Right. I was working as a groundsman. I loved math, playing math games with my father and mother around the kitchen table, but I was not an academic kind of guy, right? Working class, right? And I used to, one semester, I took my lunch breaks outside this temporary building, which I am positive 40 years later is still a temporary building. Right. And it was LA, it was sunny, and I would listen to the math lectures of Jack Stutzman in his college algebra course. So one day, Jack Stutzman, who's responsible for a lot of my career, saw the gardener sitting out there, came outside and told me I could come in and have my lunch during his class so I could hear it. And he had told his students that they could all bring their lunch to the 12 o'clock section because he knew that unless they were eating, I wouldn't be able to eat, and the only time I could work was eating. And I did, he enrolled me in his class. I did well in it, and then he shepherded me through other classes. Eventually, his brother or cousin was teaching at what was then Valley State College. Now it's like the Interplanetary University of Northridge, right? Name inflation in these institutions. And put me on a pathway to getting a BA and ultimately a PhD. When he retired, I went back to honor him and give him back the textbooks he gave me because I couldn't afford them. And I told him how much I owed him, right, for putting in my head what I could do with my life. And he said he was really proud. He said, first of all, one of the great things about being a college faculty member was that even on crappy days, and there were a lot of them, you could just take an individual student and do something wonderful for them. And that was just this wonderful idea. That was his survival mechanism. And then he said he had a whole bunch of students who he had mentored over his 30 or 40 years of teaching. But the thing that bothered him in the end was that my future and other people's future depended on a kind act of an individual. Kind acts of individuals are necessary, but why wasn't the system in place to make this a routine event that people were challenged, that their ideas about what they could be, their ideas about their limitations could be systematically challenged? He had seen all these people who came to college, this is beautiful, poetry almost, who knew that they couldn't be artists or couldn't be mathematicians or couldn't be philosophers. And he saw one of his key roles as the primary responsibility for challenging self-limiting doubts that people have. So we're going to talk about complex system changes, and I'm going to share with you what people in other systems are doing as they wrestle with the same problems you are. But we should remember that individual faculty members, that there are not going to be solutions to this that don't rely on faculty members' clarity about their roles and the possibilities of them. That's going to be central to this. There aren't technical solutions to this problem solely. The second, before I climb into the work, we heard mention of Pisa. What a disappointing turnout for the US, right, to be near the bottom of the developing countries in math performance. But then there are actually two international comparisons. There's the TIMSS and there's the Pisa. And what's fascinating, and I've been involved in both of these sort of as a governance level, and what's really been fascinating is that the US performance on TIMSS is going to the top of the world. In this last administration of TIMSS, 10 years ago, we were in the middle of the pack or slightly below. Now there are only a few countries that outperform the US, and the US is the equal or better than every European country. We're like 2 years ahead of Norway and Sweden now on TIMSS. Two states, Massachusetts and Minnesota, participated in TIMSS as if they were countries. Usually it's my state of Texas that likes to think of itself as a separate country. And it turned out that Massachusetts and Minnesota, for the first time, outperformed Japan. They were at the top of the world. White students in Texas outperformed Japanese students as a whole for the first time in history. So how could it be that on TIMSS, and both of these are extremely well-designed, elegant instruments, how could it be that we're getting close to the top of the world on TIMSS, and that some US states are at the top of the world, where we're near the bottom on Pisa? It's a great mystery, and it's directly related to what you work on in developmental math ed. TIMSS tests procedural knowledge that you learn in school. And for 20 years, we have focused on improving the quality of procedural knowledge in math in our math reforms. If you look at NAEP, the Nations Report Card, low-income students, African-American students, are now 2 years more math now than they did 20 years ago, which are big increases in productivity. Pisa does not test procedural knowledge. Pisa tests your ability to use what you learn in school in unfamiliar situations. And that has not been a focus of American education. And use of mathematics is why our students are in Dev Ed Math. They are desperate to improve their lives through education, get better jobs. You're probably seeing 5, 10, 20% increases in enrollment. People who cashing in their 401ks so they can get an education. They want to learn math for use. And Dev Ed Math is largely the high school curriculum of the 1950s, right? It's not mathematics for use. So it does show, when people look at the Pisa results, they feel that we're a complete failure as a country. And if people believe we're a complete failure, they will not get the courage to take on the challenges in front of us. The bigger lesson is that when we put our mind to something like improving procedural knowledge, schools are getting a lot better, even if it may not feel that way some days when we look at incoming freshmen. But on Pisa, that has not been a national priority. 15 years ago, I worked for the Japanese government as a consultant on their schools in trouble. So as my friend Jim Stigler was studying great schools in Japan, I was in the schools where teachers were out in the halls crying and kids were throwing spitballs and stuff of that sort. They had gotten the same results. They were at the top of TIMSS, but mediocre on Pisa. And as a national policy, they decided to address that by rebalancing their national and school assessments and curriculum. It took them 6 years, but by refocusing their goals and changing their goals, they were able to get near the top on both exams. And part of what we have to do is fundamentally questioning the goals of the courses we're in. So let's talk about DevEd. It's on everybody's agenda, nationally, in every state. And I've been privileged in my role at the Carnegie Foundation of going around Detroit, Wayne County 2 weeks ago, California community colleges last week, Texas community colleges a few days ago. Thousands of faculty working on DevEd reform. Every system is working on it. Why? Because the numbers, you quoted the 8% figure. That's actually a little better than the national average of 6% that you get from the ATD database, from the Achieving the Dream database. So 2 weeks ago, Jack Scott, the chancellor of the California Community College System, mentioned that that semester, 35,000 students in the California community colleges were taking a course for at least the 5th time. So much for lack of persistence and motivation. I remember when in the math community, we dreamed up this idea of math for everyone, math for all, algebra for all, right? What we got now is algebra forever, right, for these students. Right. 35,000 taking, almost all of them repeating a math course. I've now interviewed 700 students. We're videotaping first semester students, learning from the beautiful work of Kay McClenny, the SESI and SENS projects. And you just see these students in the 6th time taking this course. And one student said, I just want to finish DevEd before I retire. You may have seen, or you probably will see as you climb into the work, the beautiful study by Juan Carlos Calcaño in Florida, where they got the complete, Florida has a very strong data set system. They can track kids from kindergarten into the workforce. So they looked at DevEd students, not a sample, but the whole population over several years. And in Florida, they have a placement cutoff score, so that if you do not make the placement, you need to take DevEd. If you do make it, you're starting, if you pass the score, you get college ready and you take college algebra mostly. Not that students don't circumvent the system, but most students do what they're supposed to do. And they compared, what about students who just miss the exam versus students who just pass it? They're really pretty much alike. They're within the measure of error measurement of the test. You would figure that students who had the extra DevEd boost would do much better and benefit. And what you find is now in California, Texas, Ohio, and Florida, where we have large data sets, more than 1 million students, no significant bump, right, for DevEd. We can't locate any effect on student performance. We have to deal with that, right? 10 or 15 years ago, many of the students coming in, the modal image of students coming in was high school students who were sort of drifting. They didn't know why they were there. They didn't have life goals. It was a really hard population to teach for community college faculty. But now with so many adults coming back in, thousands more people than we expect, just massive increases in enrollment. The pressure on faculty to actually get this right, because they're looking at adults gambling their futures on this system working for them. I'm sure you find that. The change in population, with the textile industries here taking a big hit, furniture industries that used to be the base of North Carolina's economy, right, disappearing. All these folks find themselves at 40, 45 years old with a need to support a family. And they go into the class and what do they see? Fractions, and you can see, oh God, no, right? The veins in their neck popping. Not again, oh my God. It's like that nightmare that I still have, that I didn't finish one assignment for my PhD. I have this dream that I'm not quite done, and they're going to discover it, and I'm going to have to go back. right? That's what they're experiencing. So when we look at DevEd, before we take apart the pieces, the current DevEd program is shaped more by the weight of history than it is by our best professional judgment today, right? By what we now know about the learning sciences, or certainly by the current needs of the workforce. This is basically 16th century mathematics that we're teaching students, and we've replicated the high school curriculum in the same order. And there's an enormous temptation just to try to fix it by tinkering with it, by process improvement. And usually systems get better by process improvement rather than in product innovation. But it's time now to do both. We really have to ask some hard questions about the enterprises together. And when we ask those questions, we can't be overly romantic. We need to consider the questions in the light of our capacities and the capacities we could build. Because we have to offer stable systems of instruction with some predictability and so on. And it's going to take us a while to ramp up to be able to teach the things that we ourselves believe would be better. So these things have to happen as a system, right? When I go around to campuses, it's like we're working in a fog of collective amnesia. It's even not only hard to learn from others in our work, but it's even hard to learn from your own work because the institutional research is focused on compliance. Very hard to come across data on which students benefit from acceleration, which students benefit from modularization, right? Which students benefit from the traditional course as it is, even knowing who we're actually serving well with these courses. Right? So we have some hard work to do, and we have to do it with a deep commitment to realism, right? And relentless incremental change. But it won't all come from reorganizing the curriculum. We need both fundamentally new pathways, and we need to improve the ones that are there and offer it in different formats. So first, it's time to question the goals of developmental math education. I have 700 interviews. Arlene Arnsberger at Achieving the Dream has over 1,000, in which you're sitting there and you're looking at someone going into interior design, trying to factor trinomials. All right, policemen, firemen, EMTs. Now, I'm a mathematician, right? I get factoring trinomials. But I want to tell you that most people should not be focusing on that narrow piece of mathematics. They should be focusing on mathematics for use. Everything is organized around the old engineering program for calculus, the vestigial effects of that. Only 6% of community college enrollment in mathematics nationally is calculus. And in fact, calculus enrollment is declining in four-year institutions. And we're seeing a dramatic increase of statistics and math modeling courses, which is what many workplaces actually need. So when we start the process of DevEd reform, let's together, in our own community first, ask some hard questions about the goals. The Michael Handel study of workplace needs, 10, 20 years ago, the way people figured out what workplace needs were they'd ask CEOs and HR directors. And then several people found out that the presidents of companies have very little clue what their workers actually do. So Mike Handel, Bureau of Labor Statistics guys, went out actually at the workplace and said, show me the math. Right? Show me the math. I know you say you use it. I want to see it. I want to see those functions now. Right? And what did we see? Only 22% of workers use anything more than middle school math. They all need middle school math at a deep and flexible level of understanding. They need to know about how quantities relate to each other, covariation, interpretations of graphs. They need to know about proportionality and linearity, certain classes of functions. They appear over and over again. Many more workers need statistics than need calculus. And it turns out that the only people who need calculus need at least 2 more years of mathematics than freshman calculus. So we aim everything at first semester calculus, but there are no jobs with first semester calculus, except when it's there as a compliance requirement or filter. If you really need calculus, you need differential equations, linear algebra, numerical methods, and maybe a little more. So let's ask, what is the evidence base for the goals we set in our Dev Ed courses? And this is a critical system responsibility to figure this out in concert with our workplace partners. Right? Let's make sure we're aiming at the right targets that actually improve people's lives. That's not to say that calculus isn't beautiful. I've been teaching it every year. It has an unnatural power that's different than requiring interior designers to take calculus rather than statistics, or even nurses, many LVNs, to take calculus rather than statistics. So when you're building this on your campuses, think through the evidence base and collectively make sure there's not only a pathway through calculus, but there's a pathway through statistics and a pathway through advanced quantitative reasoning. And there's a national movement to build these. The Carnegie Foundation has convened teams, 28 community colleges and systems, working on building a statway. I like to think of it as building a statway to heaven, personally. But then I'm an older guy, right, and know that reference. Right. Building a quantway, and now just starting to think through a STEM way that really works for people who do need calculus. When you look at the Dev Ed sequence, it doesn't contain the things that calculus students have trouble with. Right? Marilyn Carlson, Pat Thompson's analysis of calculus shows what is the big problem there? Word problems, optimization-related rates, and the key problem there is geometry, setting things up. There's no geometry in any of these courses. Marilyn Carlson's beautiful work, for which she won the Selden Prize last year, actually figured out what students need in order to study calculus. None of that's in Dev Ed courses. So don't go about modernizing and improving your courses just by looking backward, right? There should be a high bar for change, but we need to look forward to make sure we get this right, because myriad people's lives and futures depend on it. Second, the course structures. There's not going to be a 16-week solution for every problem. We have some students who come in with high placement scores who really are just missing a few topics. Let's make it a fast way for them to get over it and get into regular courses, college credit transferable courses that matter. Right. Then there's a whole bunch of students who die in individualized instruction. Right? We have to make sure we know which students benefit from it and which students don't, and we don't treat it as a panacea. The hard question is, what is the largest number of options that we can responsibly manage? And how do we actually figure out what the evidence should be for advising students to take one or the other? Right? Some students need an accelerated pathway. In fact, many do. You know that 2/3 of the students who fail to complete Dev Ed nationally pass every course they take? A bigger problem than course failure is persistence through the sequence. The sequence is too bloody long for just about everybody. A very small percentage of students should be taking 3-semester sequence to get to college credit math. Right? They need accelerated versions, intensified versions, modularized versions, and versions that identify what's missing when there's a small number of things that are missing. One of the dangerous things that's happening when we don't get this right is in some states, the biggest increase is in computer-assisted instruction in which everything is broken down into a little procedure and there's no final exam. So students have to work their way through 120 procedures as a compliance activity, never have to use it and never have to remember it past 2 days. This is something that faculty should rise up. This is an affront to our educators, to the education profession. Mathematics is so, I spoke to a trustee, a governing board trustee in one of these states that's doing that, and he just said, these people don't need math. We just got to get them through the system. Treats the whole thing, educational enterprise, as a compliance exercise. Not only do we have to help students complete Dev Ed and college credit mathematics, we have a professional responsibility to make sure that students are actually learning good mathematics in it and that they'll be able to exit these sequences being able to use the mathematics either for future education or in the workplace. And it may be possible to get a bunch of students through something in a way that really threatens the purposes of education and is antithetical to the mission of higher education. So we have to ask not only questions about what's most efficacious, but which ones reflect the positive vision of education and are in the long-term good for the students we're serving. So, what does the work look like? And what's going on in other places? Well, first, there's a wonderful paper by a woman named Adriana Kazar, who looked at 623 plans for reforming some aspect of college education. And what she found is these were proposals to the National Science Foundation for support. Every one of them focused on one level of the system. It was either about math teaching, pedagogy, curriculum. It was about administration and administrative capacity. It was about governance and policy. And the fact is that these system issues require coordinated activity at every level of the system. They require a joyful conspiracy. This, I think, is why you guys have a big leg up on this, that your president understands this. And the challenge is to figure out, not just to bring the math faculty together, but bring you together with the chief academic officers. The student support people will need to be in this, and the governance people. Because unless we coordinate change at each level, we're not going to be able to fix the broken systems. This isn't only on the back of math faculty designing new courses. This is a complex system problem. So what are the issues that we're going to have to take on? Placement. All right, here's like really bad data. This is like from Ghostbusters, like Old Testament bad. Rivers of blood, locusts, frogs, death of the firstborn. So what is, in California, Jessica Howell's study, what is the high school math GPA of students who place into elementary algebra in community colleges? 3.1, slightly over a B. So when students come in and get placed in this one-shot deal, right? They come in, they've taken the summer off, they sit down, or they've been out of school for a few years, and there's one moment where they get placed. They're rusty, right? They come in thinking they're prepared. They passed high school courses, right? They got a B in them, and now they're being placed back. You think this is an anomaly? About 25% of students who go to early college high schools, which are really strong instructional programs, taking courses taught at the community college, about 22% of the students who pass Calculus 1, when they take the placement test, get placed in intermediate algebra. This is like really bad. This is like college readiness, where 1/3 of your college graduates are now college ready. Right? This is a horrible system. In Massachusetts community colleges, we got together a group of faculty looking at students, really, sort of faculty leads, chairs, and people who have been advocates for improvement, along with more traditional people who really are the responsible leaders of their departments. And we looked at this, and one wonderful guy had the idea, let's do an experiment. Instead of putting these students in Algebra 1, first day, we're going to invite them to a 2-hour session, and we're going to give them the final exam for Algebra 1, for the course they're now entering. And what happened was, a whole bunch of the students, they went, I don't remember this, I never learned. They go, oh yeah, I sort of remember this. It's just like a little different, but I think, yeah, oh. And the students were able to do most of the items on the final exam for the algebra course they were entering. And this guy, who is a sweetheart, looks right into the camera and he says, oh my God, they know it before I teach it, but not after. I mean, he was so genuine. I mean, this is like this crushing, right? So what are we seeing? We're seeing more and more places moving away from one-shot deal assessments. Building systems where students can practice first. In fact, where they're required to practice first. And what's happening in those systems? Students are being placed 1 or 2 courses closer to where they need to be. It's crazy to make life decisions based on a one-shot deal, right? One moment, often with students have no idea of the high consequence of what they're doing. That's professionally irresponsible. There are all these systems, Alex and others, there's at least half a dozen systems now for you to look at, where students not only get a chance to practice as much as they want, but they also get a fairly clear diagnostic assessment of what they know and don't know. Right? And then it turns out when they're told what they don't know, they go, yes, I do. And then they go, oh, yeah, I remember that. And then it just comes back into memory and so on. So we need to clean up the placement process. Sharon mentioned that Scott was the right guy for the right job at the right time. We need reliable systems for getting the right student in the right course at the right time. The more students who do not need to take several courses, the better for our system. And one of the reasons now it's so important is because of the massive increases in enrollment and the actual threat that's realized in many states, Nevada, California, of turning away students who need the mission of our institutions. We have to be more efficient. We can't be, just have students taking courses over and over again that are dumb courses anyway. Right, so we have to fix this. Articulation. So I chair the Department of Defense's, I'm a military, chair of the Department of Defense's studies for military families, mobility in military families, and the effects on a children's education. The number of active duty soldiers, the number of vets who move around from state to state and discover that the course they took in North Carolina doesn't work in Texas. This is really stupid. Right? It's like a littered landscape of lost credits. And in most states, you guys are a little ahead of the curve here, in most states, each individual community college has to articulate with the campuses that it wants to articulate with. In one case, you have a dyspeptic math chair who just asserts everyone needs to take calculus. If you don't take calculus, not a pre-calc, but calculus, if you don't take that, it's an affront to equity. We're closing people's options. And in many institutions, the administration is loath to annoy the faculty. Right? Why are you smiling over there, Scott? Right? And we built a system where one person can make a decision that really is a policy decision that needs lots of different stakeholders. Right? So we got to look at articulation questions. We need to make it easier for people to aggregate legitimately earned credits. Right? Make it faster, easier for them to do that. And we need to start doing that within our systems. And North Carolina actually thought pretty hard about this. It has a more rational system, but we need to work to improve it. The next is student support systems. So what do we know about these students from the SENSE studies? More than 80% are absolutely positive the week before they start that they'll succeed. A majority of African American students, when they start community college, are actually seeking a postgraduate degree as their endpoint, not just a degree. Right? Motivation isn't the problem, nor is persistence. But now when we go follow them through the first 3 weeks, you see this incredibly painful cycle of disinvestment. We're just interviewing hundreds of students. We see it all over the place. Student comes in, I'm going to do this. I'm ready. I may not have had my act together before. I am ready. I have the skills to do this. I need to do this. I'm going to do it. That's the normative response from students. First assignment, what the hell am I supposed to do? They're gobsmacked by the pace at which we go in community colleges. They look at the homework, they have no idea what it means to do the work. And no one is too clear about it. The advice is all based on folklore that they get. 2 hours of study for every class hour. This comes from 1860s moral education in religious colleges. It's not the result of an evidence-based, piece of research. So the students are sitting there. They have no idea what to do. They immediately, by the end of the first week, tell you, more than 3/4 of them, that they've slightly lowered their estimate that they'll be successful. They still say, I'm going to be successful, but I'm not quite as sure as I was before. As soon as people are not quite as sure, they hedge their bets. And we can see from work data that they increase the number of hours they work by half an hour on average. They're hedging their bets. Right? Next, second week, they miss their first homework assignment, or third week. Fourth week, they miss their first class. And you get this cycle of disinvestment. If I really believe I'm going to succeed, I'll focus on it. As soon as I draw back, I hedge my bets, I do something else, and I pull myself out of the system. And we have all these tapes of students saying, well, I sort of missed the deadline, I'm going, but I'm not really doing any work. I'm sort of embarrassed. I didn't know what I was supposed to do, and so on. More than half of them dramatically lower their aspirations. This is really bad. Right? We now know that a very large number of first semester students in Dev Ed believe that you're either good in math or you're not. They do not actually believe that effort will pay off. This has been shown by Carol Dweck and others. Just massively good studies, David Yeager's studies, that in fact, if students have the wrong idea about learning, they're not, in fact, going to persist. So what do we do to address this? We have student success courses. So we've surveyed about 50 of these courses. They have learning communities. But when you actually look at what's in them, there's no similarity from one to the other. Almost all of the student success courses were created by a caring group of people who put in it what they came across first. So at South Texas College, which is a wonderful institution, student success, 3/4 of it is about emotional intelligence. Because the great guy who teaches it, Spud, his name is, he had a need for dealing with emotional intelligence. And when he came across these ideas, they really improved his life. So now their institutional program is about emotional intelligence. Then you have a bunch of these things that are about study skills. So we've taken them apart and searched for the evidence base for the study skills. There is no evidence base for the study skills. And why is this dangerous? Because the students who are disconnected from others, the people who come in as individuals, who are out of the higher ed loop, have no way to figure out what the real requirements for success are. So advising, when it isn't based on a real rock-solid clarity about real requirements for success, actually sends you in the wrong direction. And the students who have networks, who have friends in the classes, who have cousins who took the classes, they have a way to figure out, independently of us, what you're really supposed to do. But a very large number of the students we've been interviewing in Dev Ed have no clue what they're supposed to do. They don't know how hard they're working, and they have no understanding of how hard other people are working. The most common comment is, this was hard, that means I can't do it. When you interview the successful students, they tell you, okay, I'm going to learn something now. Their response to struggle is, well, this means I'm going to learn. I may not get it all the time, but I'm going to learn. Whole bunches of students, as soon as it's too hard, they go, either I can do it or not, I'm not smart enough to do it. And they have this self-limiting, horrible, psychologically invalid theory of learning that's going to lead them to disaster. For them, struggle means you're a failure. For others, struggle means you're going to learn. We did a controlled experiment, randomized controlled experiment of interventions that shaped students' views of themselves as learners. Got big jumps in 4 institutions in effect. So we're just starting to see community colleges now redesign student support around real evidence, deal with the first 3 weeks. We know what percentage of students in our institutions actually don't even know they're eligible for financial aid. Very large percentages of them, like 1 in 8, don't know you can use it for personal living expenses. All right. So we have to have an evidence base for the advice. It can't just be about caring. Caring matters, but rock-solid clarity about the real requirements for success matter a lot more. And institutional research has to be tasked with getting real answers to questions that affect student success. One of the quirky and odd and disorienting things about visiting so many campuses, usually when I go visit campuses, I go for 2 days. The first day I just teach. I substitute in 4 classes: arithmetic, algebra, intermediate algebra, and pre-calculus or calculus. I've learned to do that because when you speak to presidents of institutions, every institution sounds identical. What has scaled is the language for talking about higher education. I mean, identical language. Everyone has learning communities. Everyone has this, right? When you teach, it's stunning how different one campus feels from another. You go to Valencia or LaGuardia, where I was a few weeks ago, about a month and a half ago, and students feel connected. There are students all over the place after classes, and they're working adults. I mean, they're connected. They can name the other people that they work with in social media. They actually can tell you the names of the courses they're going to take next year. And you go to other campuses, and it feels like a gas station where students just sort of drive up, get filled up, and drive away. We can affect that, right? But this is totally invisible to the presidents of these institutions because they all have the checklist of things that constitute an excellent community college. Right? But if students aren't actually connected to the institution and to each other, they're going to overly rely on faulty advising systems, and they're going to have no self-correction mechanisms. So we have to think about student support services that are much more integrated with actual instruction. 40 years ago, faculty's role, advising was part of faculty's role. And then it all got professionalized out into learning centers. I remember thinking, if they're the learning center, what are we, the faculty? Right? It was all professionalized out. And now it's time to start gradually rethinking what parts of student support should be recentered in faculty roles. This is a hard question because faculty are overworked. Course loads are going up in many institutions. Class sizes are going up. But we have to revisit this total separation of student support from instruction, right? Especially given the number of people coming to our classes who really aren't academically oriented, really aren't, in the college culture. How do we acculturate them? Not only to mathematics with its precision, right, but to figuring out what the enterprise is and the goals. Really important. So I've talked a little about the goals. Here's a worry. I always hear my mother's voice. My mother's comment on the back is, "Son, you can never worry enough." She was brilliant, but there were some messages I would have preferred not to heard till later. One of the things about Dev Ed is it's easy to focus everything on the failures, but we had better figure out first who we're successful with. Because there are students who go through these things and use these things well, and we should have very clear profiles in mind when we undertake Dev Ed reform of the faces of the students who we're successful with. One of the things you're going to find as you do this exercise, as they've done it at Pierce and other community colleges, is a lot of the students we're successful with were surprises to us and to the students themselves. And one of the things that happens when students succeed in one of these courses is it emboldens them to raise their aspirations. I'm sure you've all seen this with students in your classes. They go through this stage of, I am free, I can do this. Then they get really angry that they didn't get this together beforehand, angry at themselves more often than at others. And then they start asking questions about, what can I really do if I can do this? Because math has such symbolic importance in the culture. We have to be very careful when we build new pathways that we don't inadvertently close out options. One of the hardest pieces of work in Dev Ed reform is going to be, how do we change it in ways that increase the likelihood that successful students can transfer into things that they now want to do? And that requires looking beyond the boundaries just of the courses themselves. I mean, it is thrilling to hear and look at the videotapes of students. Young woman just wanted to be an aide, an attendant, healthcare worker aide. And she comes through this, and she does well. She's really got, her algebra course. And she goes, why don't I want to be a nurse? Right? Well, what are you supposed to do to be it? She didn't have any idea what it meant to be that. She had no vision of the landscape. It was really important. So at Los Angeles Community College, one of my many, I went to 4 different community colleges at the same time, probably like some of your students. You go down there, you speak to these students, and they really don't understand what their lives could be, and so many of them cannot name the math course they'll take the one after the one they're in. They don't even know the names of the courses they're in. They have a graduation plan. It's the thing they look at the day before they graduate. Right? We need in our Dev Ed courses not just to teach them important skills, mathematical ideas, concepts, and procedures, but we need to build into these courses a roadmap of where these courses take you and how they're connected to their opportunities, and we need to test the students on this. There's nothing that says that mathematics courses, while primarily about math, can offer instruction in the importance of mathematics and the ways that it affects your options. In too many community colleges, there's no systematic challenge to students' low aspirations or limited aspirations. And I think it's going to be hard for advisors to make compelling cases for math. It best happens in the math courses themselves. So as you start redesigning these modules and these units, think creatively about how you might be able to include a unit that actually helps students understand the landscape they're in mathematically. What is the sequence of courses they can take, and how does it affect their future life opportunities? Actually, interviewing students is so interesting because we thought like they think in terms of jobs. And so many of these students don't know what the job titles mean, especially the younger ones. And what they're actually interested in are things like, will I work for others or will other people work for me? Right? We got to make sure we understand what questions really are on the minds of these students. And we need to integrate little pieces of advising and orientation and career information into the courses where they'll have reinforcing effects on motivating students to persist. Right? These courses need to focus on what we've learned from the learning sciences. Productive persistence. Students need to be oriented to the fact that we're going to make them struggle. Why are we going to make them struggle? It's a planned activity. We're math faculty. We can aim it just over their heads. That's what we're trying to do. So when they experience struggle, they should thank us and know that we're competent, and that every so often we'll screw up and aim one too far over their head. And that's a sign that we misfired, not that they're dumb. They need to understand productive persistence. We need to be careful about robust connections so that students aren't learning everything as a self-contained little atom of information that can never get retrieved in memory. Here's a fantastic study. It's in J.R. Anderson's book on learning sciences, The Architecture of Cognition. Big research field now. The situation in which you learn something affects your ability to retrieve it from memory. So they did this great study where they taught one group of students certain math tricks underwater, I'm not kidding, and another group above water. And they tested them 3 weeks later, and the students who learned underwater actually were better at retrieving the tasks underwater. Now, this could be misinterpreted, and I don't want to see a headline that Scott Rawls inadvertently drowns 2,000 community colleges. Horrible tragedy and misuse of data, misuse of research. But actually, we also know that if students think that the math they're learning is going to be used in a job, or they're going to use it in other math courses, they store it in memory in a completely different way than if they think it's only a compliance task for a test. So we need to think about the connections we make and the perspective on this, not just the tasks themselves. And then, of course, deliberate practice. Practice is incredibly inefficient in community college dev ed courses. What people are doing with Agile Mind, some of the Carnegie tutoring stuff, is they're actually, for every homework problem and every instructional task, they have an evidence base and a contingency matrices. If you use this homework problem, what's the probability that if students can get it, they can do these next problems? So we did that in our institution, and wow, was it humbling, because half of my favorite problems predict nothing. And it turned out that a lot of the problems, this is really humbling. A lot of the problems I love to assign, I like to assign because they're a little quirky and make you see things in another way. And I was assigning way too many of those because I happen to like them. And I actually had no evidence about the predictive power of the problems I was assigning. So when you have resources to study your own teaching, I'll just mention on a tangent. 2 years ago, I was working on, every year I have a project I work on as a teacher. I appoint the student committee, and they meet with me every 3 weeks. And they evaluate me on their ability. They tell me 2 things I can do to improve my teaching. I tell them something they can do to improve their learning, and we evaluate each other. So one of the things that came out from the year before was that I make up these metaphors for things that students really liked. So I figured out, okay, I'm going to have someone study this. So Michael Ortman, now really PhD, superb math educator, found 5 examples of metaphors I used in teaching limits, and then he tracked the students over the semester and found out where everyone backfired later in their understanding. And he wrote his doctoral dissertation on this, on my failures as a teacher. Best piece of work. We almost never have anybody check up on us, and we have almost no capacity to check up on whether our ideas, instructional ideas, actually work out. And we need to figure out how to really work on this. And I think the place to start is on building better instructional tools for faculty that faculty can use creatively in their classes. Validated tasks. These are standardized programs. We should have performance data and specifications for the items that we usually use without limiting our ability to do things on the fly in response to things we see. But right now, many of the folks have no tools for doing this. And here's the direction it's going. Wayne County Community College is now the 2nd largest producer of African American associate's degrees, certificates, and licenses. It's a very large community college. They're down to only 3 full-time math faculty and more than 120 adjuncts. Half of the adjuncts are now hired by temp agencies. Why? Because they have almost no mid-level administration left. We're seeing this in Nevada. So the trend is toward automating out the faculty role. Right? This is really bad. And it's happening all over the place in response to incredible legitimate fiscal pressures and to hard questions about the efficacy of the systems that depend on us as teachers. We as a community of faculty and administrators need to raise the evidence standard for every aspect of our work. Otherwise, I think we're going to be in deep trouble. That means we need to work collaboratively with our professional associations. Carnegie Foundation for the Advancement of Teaching took 2 pathways, the STAT way and the quant way, haven't begun on the STEM way yet, and we got all the professional associations to come up with a sanctioned set of outcomes for those courses. If we're going to really do this, change Dev Ed, we have to make sure that we change it in ways that are okay for people moving around a lot. We can't just make it overly local. We need to have national standards set by our professional societies and our institutions that guide the new outcomes that are relevant for today's needs, not the 16th centuries. Right? And that's going to require new forms of faculty engagement in this work, which you guys are setting up and structuring here with your Dev Ed math community. Now, let me just end this little piece with why this is so important. We're the institutions that actually are the vehicles for upward mobility in this society. When people think of higher education, like on my curriculum vitae, they write that I got my PhD from Berkeley, or they think of the Ivy League. So I'm at Manhattan Borough Community College 2 months ago. Sadie Bragg, you may know, great associate VP. And I realized that there are more low-income students, more African-American students, and more Hispanic students at that one community college than in the whole Ivy League combined. I bet there are half a dozen community colleges in your system that individually have more low-income and students of color than all the, elite for-profit institutions, right? All the elite higher ed, Harvards, and so on. If you look at the Ivy Leagues, only 3% of their students are from the bottom quartile of income. They're not really about creating pathways to upward mobility. We are. That's the core mission of our institutions. And it's really important now for the fabric of our democracy and our country. It's not just about better math. We have more and more people who through hard work became middle class, returning to the lower classes. Democracy is not going to persist here because of the founding fathers and the Constitution. It requires a belief in the people that they can better their life through hard work and education. When people don't believe that there are pathways to success, it creates civil unrest in countries. Weimar Republic in Germany. We're at a very critical point in the fabric of our country, increasing polarization. Critical to the fabric of our society is institutions that allow people to get more for their families and their communities through hard work and education. That's the real purpose and mission of community colleges. It's not just workforce preparation in the narrow sense, but that's a critical component of the work. What we're doing really matters, not just for our students, but for our country. We have to remember that, and that's why we have to get this stuff right. Whatever your political persuasions might be, we're Americans, and one of the great things about American higher ed is its second chance system of advancing. Very few countries have anything like our community college systems. We're entrusted with making them work and making their missions real in the lives of students. Thank you. I'm going to let them talk and take questions. Thank you. So before I take questions, being a classroom teacher, professors must profess, of course, is I want you just to take 3 minutes with your neighbors and decide what you really want to ask. Because all of you know that actually generates better questions in your classes. So talk with each other and refine your questions.
Okay, let's pull those great ideas together. Lots of energy, lots of great ideas floating around in the room. We want to give you an opportunity to ask Dr. Treisman whatever burning questions are on your mind, or just simply to make comments about what he has talked about this morning. If you'll notice, there's a microphone in the middle of the aisle, and I will ask that so that every person in the room can clearly hear every question, that the person asking the question please go to the aisle and speak into that microphone, okay?
Or I'll call on you individually.
Mine's going to be a simple question. I was trying to write down the names of some of the research studies and the people that you mentioned, like McClenny and Carlson, and I couldn't tell whether it was Geyser or Kaiser. If you could spell those names for us so that we can look it up.
So we need an organized way to connect up. Actually, Jobs for the Future has amazing depth of knowledge about the field. But I talked about, the first one you said was?
McClenny? Kay
McClenny. So Kay McClenny is, I think I informally think of her as one of the goddesses of community college reform. She runs the Community College Student Engagement, CESE, and the SENSE studies. So McClenny, M-C-C-L-E-N-N-E-Y, and
I've got somebody transcribing it for me.
yeah, that is a gold mine. And connected to that is something called data notes that's collected by Achieving the Dream, JPL for Achieving the Dream. They have done large-scale studies of almost every single aspect of DevEd across the country. More than 500,000 students in their database. And you could look at the characteristics of students who pass DevEd and still don't complete the math sequence. All of these things, that's a gold mine. Marilyn Carlson at Arizona State University was the winner of the Selden Prize for figuring out what you actually needed to know to do calculus from algebra, the role of covariation and quantification. So what we need to do, if you want more of these things, is when you have your leadership group, we need to connect up.
And Dr. Treisman, I will add that we will send out a list of a bibliography. How about that? We'll
Yeah.
send out
That
a
would be
bibliography
great.
to
Yeah.
all of you.
That would be great. Right, thank
Yeah.
you.
The one I didn't mention that you'll find really interesting is something called 90-day cycles that were initiated by the Institute for Healthcare Improvement in the healthcare industry. You may have read Atul Gawande's book, Better, or The Checklist. These are things that you should all read the book Better by Atul Gawande. He won a MacArthur Award for this, and it talks about how they solve similar problems in hospitals. So Carnegie has emulated that, and they've just finished so-called 90-day cycles on getting the right student in the right course at the right time. They did one on academic boot camps, which means they surveyed the national field, they interviewed the leaders, they described the common elements. And then David Yeager's, which is a masterpiece on the core drivers of college success strategies and what the evidence base is. He found 28 different goals of student success courses, and then he found the evidence base for each, what the research was, and what kinds of students it was actually based on. So there are these gigantic structural engineering projects figuring out what is the stuff we should read when what should we read that we combine with our practice wisdom and local particulars to actually create the next iteration of our work. Yes?
I was trying to get it to my level. Okay, one of the things that you mentioned that I was intrigued by was this idea of validated tasks.
Yeah.
As, you know, someone who's always trying to improve her performance as an instructor, but also being on this task force, if there's I don't know, this seems like it's an idea that hasn't been researched very much yet, and at least that's what you indicated. That to me is a really powerful idea, that if, as the task force, we could incorporate validated tasks into the modules that we're creating for this, it would just, make the pathway that we're trying to create be so much more powerful and successful. And I just wonder, could you talk maybe more about what's being done on that, and, how could we incorporate some of those ideas into the work that we're trying to do?
Most of this work is taking place at the K-12 level, and there have been several either companies or public-private ventures, wireless generation at the elementary school level, Carnegie Tutor and their data mining projects in high school math, Agile Mind, which has 500,000 high-poverty high school students online and 20,000 teachers. So what they've done is use modern data mining to take each item and then look at its correlation with success on later items that we think it's supposed to prepare you for. I'll just say something about this that was surprising. One of the things we found is about 400 items that after students did them, they stopped, whether they got them right or wrong, they didn't do any more problems. And then there were a whole bunch of problems, whether they got it right or wrong, they always chose another problem. So we gave these problems to motivational psychologists, and they really struggled with trying to figure it out. So we repeated the study with a different population and got the same results. When you actually have data, which you can get from online, your online versions of courses, where you get all the keystrokes and things of that sort, we're starting to get completely different sets, different kinds of knowledge about what we assign students to work on. In my military life, DARPA is doing some work on this too with military training. So this is a new, completely new area. And you might want to put together a subgroup of your team to think about how do we use technology to not replace teachers, but to improve the quality of tools and tasks that teachers use. Now, I think this is going to be a major developmental area. We could see it taking off in K-12. And I haven't seen it yet in community colleges, but it's an opportunity. I think that we'll see as many gains there from any changes, as many changes in pedagogy. I think that's going to have to be even more important. We have to be efficient in course structure and patterns, but also in what students actually work on.
I have a question. Are you seeing faculty bypass IR and begin to collect their own data so that they can get quick time response instead of having to wait to fill out the form, get the signatures, and then you get the data about 3 or 4 months later? Are you seeing them sort of create their own databases and keeping the data like that? Thank you.
Actually, what's most exciting is Richland Community College, Valencia, Mount Sac. They've restructured their IR so that part of it is about the mountain of compliance stuff that you have to do for legislators, reports you have to write. A senator comes up with a question and you need an answer tomorrow morning. A lot of that's not going to go away, frankly.
Right.
We can make it better. A lot of it's not going to go away. But they're retasking and building their IR capacity so it actually supports instructional improvement. And I'm seeing that on more and more campuses as a strategic goal of the campus leadership and the system. What portion of IR energy should go into improvement? What portion should go into system issues and compliance? But I am seeing more and more faculty groups. I'm working with 26 of them at Carnegie, where there are teams just like this, almost identical in makeup to this, working on the details of their courses. And what we need is an IR person, the dean, the math chair, the dev ed person. The only difference is we've included the IR people in these teams. And you might think about that, at least for some campuses as a pilot.
So how did these faculty get to work with you? Because I think I emailed Carnegie, but I haven't heard from them back. I mean,
Well, it was personal. You have a reputation. So Carnegie is moving from its 26 or 27 partners. It's going to triple in size. But actually, what we need to do is figure out what are the strategic connections. And in our carnegiefoundation.org website, you can see a lot of this. But you need to pick a few people, and we'll pick a few leaders of ours and support a common retreat. We need better ways of sharing information across systems. We can't all do it completely by ourselves. It's sort of dangerous to do it that way. But I'm not saying in any way that local particulars don't matter. And just in looking at this, we think of it as identifying practices worthy of attention and re-engineering them for use at scale. When we go to Valencia, LaGuardia, there's beautiful things, but they're like 3 parts based on local particulars and 2 parts based on great ideas. And the trick is to sort of look at these, re-engineer them so that they can be more easily used by other people, separate out the local particulars from the good ideas, and that's what we're trying to do. And I'm sure, I have no doubt, there are tons of good ideas in this system. It would be a pity if other people didn't learn from them. And if you had to rediscover things that other people had actually figured out, not just on one campus, but on 20 campuses, like some of the placement stuff, for example.
I'm just curious, is there some research out there that shows how social networking, which is so much a part of our students' lives, how it's being used for a directed purpose in success of this nature?
Yeah, so we met with Facebook, Google, with their senior researchers, and we discovered, I felt old. I know, I'm really old. So the first thing I discovered was Moira Burke's work at Carnegie Mellon, who's a senior researcher for Google and for Facebook. They have identified, they have a data set to die for, right? They have stuff they shouldn't have, let's put it that way. What they've done is they figured out the characteristics of interaction and welcoming people into Facebook that result in sticky communities. So the University of Phoenix guys and Kaplan have actually created a company to mine their data to learn about stickiness and persistence. So the things they've learned is how you're welcomed in matters, and there are certain structural things of that. First of all, being welcomed in actually matters tremendously. Requiring people to interact twice a week with peers in a way that's auditable dramatically increases persistence. So they have a whole theory of this, some of it proprietary, but you just buy them good wine and they tell you everything anyway. So much for corporate security. I like to think of myself as a sommelier to America's math educators. So there's Moira Burke has published a lot on this, actually. We need to learn. This is a place where the for-profits actually have done more work than we have. And when I spoke to the leadership team at University of Phoenix, I asked them why they were doing it, and they said it reduces their advertising costs. Because the stickier their communities, the more their sales and enrollment comes from word of mouth. So that was actually what drove their expansion. And we can learn from them. They have a lot to learn from us, but we can learn a few things from them on this. Now here's another lesson. When the companies, the for-profits and some community colleges, Rio Salata being an extremely interesting case of this, very interesting place. When they tried to co-opt social networking around the academic purposes, it always failed. Students do not want their regular social networks to be infiltrated by us. On the other hand, they're open to being invited into ones that we create for their benefit. And we got to get rigorous about that. This is an engineering problem and a design problem, architectural design problem. Thank you. That's really important stuff. Thank you for asking that. And it's B-U-R-K-E, if anyone wants to go find it, Moira Burke. And she has a bibliography of everything that's known about stickiness. Just before your question, one of the first things they studied was an online mechanism for developing good jokes. And they had more than millions of people writing in jokes and editing them and refining them, and then rating their effectiveness. And they get it down where they can tell you a joke online in 3 seconds, in 3 tries that will crack you up. And you'll see, I mean, some of this, I just had no clue that this stuff was out there.
I'm curious about your experiences with ABE,
Yeah.
adult basic education programs, as a transition to
Yeah.
development, or even a pre-developmental type program. And I've looked at some of the studies in New England
Yeah.
that's happened.
The one that most impressed me was iBest in Washington State. They seem to have the best data. It's still not fantastic data, but people were so relieved to find anything that worked, right, with ABE. So the iBest people have really come up with their own sort of integration of learning community, vocational counseling, advising, in a package with courses that work. And they're getting more people through to regular courses or to certificates and licenses than I believe any other state. Although there's some interesting stuff in the Massachusetts area and New England. But if you're in ABE and you don't know about iBest, it's worth a close look. You may want, if you have ABE, you may, if people don't know about it, you may want to send out. We're way ahead on that. Yeah. It's good stuff. But that's an area that is really hard, and even though iBest has advances, it needs lots more work. Other questions? Look at that. It was a pleasure to be here, and I hope we'll find ways to collaborate. And this is not work for the faint of heart. So these systems are deeply embedded, historical things. And we should have a very high bar for changing things on campuses. Stability matters, predictability matters, but we got to make some changes in this system. Thank you.